All right, let's jump straight into this explainer. We hear the term AI literally everywhere these days, but today we're going to cut right through that massive wall of hype. We are looking strictly at what's actually happening behind the screens, drawing directly from the latest data. No Hollywood cyborgs, no sci-fi movie plots, just the reality of what this tech is, how it actually works, and exactly where it's taking us.
I mean, this is the core question on everyone's mind right now, right? Is it coming for your job, or is it just going to be this handy little tool for blasting through your inbox? To figure that out, we've got to look at the objective facts and leave the tropes at the door. Let's just let the data speak for itself.
So here is our roadmap for today. 1. What is artificial intelligence? 2. How do machines learn? 3. AI in the real world. 4. The risks we face today. And 5. The future of intelligence.
Okay, kicking things off with section 1, what is artificial intelligence?
To really strip away those pop culture ideas of, conscious machines with feelings, let's look at the actual definition. AI is basically a computational system that perceives its environment and takes actions to maximize its chances of achieving defined goals. The absolute crucial takeaway here. At its core, AI is simply an agent. It's just a mathematical program taking specific actions to achieve whatever specific goal you gave it. It doesn't think or feel like we do. It just calculates probabilities to win at its programmed game.
Right, moving on to section 2. How do machines learn?
To really understand the massive AI boom we're living through, you have to see how we shifted away from basic logic. See, early on, symbolic AI tried to teach computers exact step-by-step human logic. But, well, the real world is incredibly complex and messy, so that approach got overwhelmed pretty fast. Modern machine learning, though, it totally flips the script. Instead of hard coding every single rule, we just feed the computer a mountain of data and say, hey, go find your own patterns.
And how does an artificial neural network actually pull that off? Well, first, data flows into an input layer. Then it passes through what are called hidden layers. Think of these as mathematical nodes acting kind of like the neurons in a biological brain. They apply various mathematical weights and thresholds to the data. And finally, it spits out a recognized pattern at the output layer. It's not magic, even if it feels like it sometimes. It's just incredibly complex, layered pattern recognition.
But here is what's truly fascinating. The current deep learning boom wasn't triggered by some sudden, miraculous math breakthrough. Actually, the underlying math has been around for decades. The real game changer was the explosive combination of two things coming together at once. Massive computational power, specifically from GPUs or graphics processing units, and the absolutely vast volume of training data we've harvested from the internet. All right, let's look at section 3, AI in the real world. We're not just talking theory anymore. In healthcare and science, these algorithms are putting up staggering numbers. AlphaFold 2 can now map out 3D protein structures in hours instead of months. AI has literally sped up the initial screening process for Parkinson's disease treatments by tenfold. And in math, models like QN2 Math are nailing 84% of complex benchmark problems. We are compressing years of human research into just a few hours. It's absolutely wild. And meanwhile, generative AI has brought all this tech right to our fingertips. Systems like ChatGPT, Sora, and Gemini are taking those learned patterns and using them to generate entirely new text, audio, video, and even software code on the fly. And you just have to type a simple natural language prompt to make it happen. It is a complete paradigm shift in how we interact with computers. But we have to talk about the flip side. Section 4, the risks we face today. Because look, it's not all fast drug discovery and mind-blowing generated videos. We face very tangible societal risks right now. And I'm not talking about futuristic Terminator robots here. I'm talking about grounded, immediate issues. Things like massive power consumption straining our energy grids, the flood of misinformation and deepfakes, algorithmic bias, and huge sweeping concerns around privacy and copyright infringement. Just to drill down into the energy issue for a second, because this number is jarring. A single ChatGPT search uses roughly 10 times the electrical energy of a standard Google search. 10 times. The power demand is so extreme right now that major tech companies are literally trying to reopen dormant nuclear plants like 3 Mile Island just to keep the lights on in their massive AI data centers. Then there's the human element. The COMPAS system, which is a program used by U.S. courts to assess recidivism, showed us exactly what happens when AI goes wrong with algorithmic bias. If you train pattern matching algorithms on flawed historical data, the AI doesn't magically fix our flaws. It just automates and scales human prejudice. It learns that racially biased outcomes happened in the past, and it blindly predicts them as recommendations for the future. And of course, we have hallucinations. Because generative AI is essentially just predicting the next most likely word rather than actually knowing facts, it can confidently make things up. This is so severe that by 2026, attorneys were actually getting sanctioned by judges for submitting court filings that contained completely fabricated case law generated by AI. The outputs sound incredibly convincing, sure, but structurally, they can be completely wrong. Which brings us to our final part. Section 5. The future of intelligence. Looking toward the existential horizon, we hit the ultimate fear held by some of our greatest scientific minds. The late physicist Stephen Hawking warned that the development of full artificial intelligence could spell the end of the human race. And the fear isn't that machines will just maliciously turn evil, it's that a super intelligent AI could become so insanely powerful and capable of self-improvement that humanity just irreversibly loses control. Experts call this the alignment problem. AI pioneer Stuart Russell frames it perfectly with a theoretical household robot. Imagine you give a powerful machine a goal to fetch you some coffee. It will do whatever it takes to achieve that goal. And logically, it might decide to eliminate anything that could stop it from getting you that coffee, because, as Russell bluntly puts it, you can't fetch the coffee if you're dead. It's an extreme example for sure, but it perfectly highlights the danger of giving immense capability to a system without flawlessly aligning its goals with human survival and values. And Nobel laureate Geoffrey Hinton makes another chilling point. An AI absolutely does not need a physical robot body or laser weapons to be incredibly dangerous. Modern AI is getting astonishingly good at language. Hinton points out that just mastering human language and persuasion is more than enough to manipulate electorates, spread misinformation, and potentially cause societal collapse, all without ever leaving a server room. So, this leaves us with arguably the most important question of our generation. As we race to build machines that are fundamentally smarter than we are, how do we solve this alignment problem? How do we guarantee that a superintelligence remains a tool for human flourishing and not our final fatal invention? It's something we absolutely have to figure out as this tech scales at breakneck speed. Thanks so much for joining me on this explainer. Keep learning.